Okay, so I am re-recording this video. Had some issues with GoToMeeting's record button. This will be the second time I've given this this lecture, but we are good to go. So basically, we're going to be covering the observer pattern, as you can see here, and I might go a little bit faster than intended, but should be pretty straightforward. And we'll be going over the observer pattern, and the next time we meet we're going to be going over UML. So observer pattern basically defines a one-to-many dependency between objects. This is so that when one object changes state, all its dependent objects can get notified and updated. Graphical editors are a good example of this, because when one particular part of the graphical editor changes, I'm going to get my webcam into view here, then all the other parts of that graphical editor can be updated. So the idea here is that we want to maintain a consistency across related objects. And so if we have observers registering themselves to subjects, that way if the subject state changes, all the observers can be notified. So it's sort of a self-registration system where the observers need to register themselves with the subject. What's going to happen in this system is that basically it's going to be an abstraction. So one aspect of this is going to be dependent on another, and we can encapsulate this in object-oriented style so that essentially the observer doesn't need to know about the actual details of how the subject is updating itself. It just needs to know that it's going to call an update on the concrete observers once it actually gets to that. So what that looks like is basically we have a subject that's being registered inside of an observer, so that whenever the subject does its update, it calls notify on all observers that are registered. Since we've got an object-oriented hierarchy here, it's going to call O_update, which is going to go into the concrete observer and actually do the real update. So the subject is responsible for knowing all of its observers. It's got a list of observers essentially that it has to update. All the observer has to do is define that update interface and when it should actually be called. So the concrete subject stores the state to the concrete observer, sends notification to the observers when that state changes, and all the concrete observer has to do is essentially register itself for that one time. So again, the concrete subject notifies its observers when the state change occurs. After being informed of the change in the concrete subject, the concrete observer can query the subject for more information if it needs to. The way that looks in a sequence diagram is like this. We've got the concrete subjects saying having set state called from the concrete observer basically changes the subject state, but then the actual get state is coming from the concrete subject. It's not coming from the observer. So here the observer actually initiates that change request to set the state, which is kind of interesting. So observers can actually request a state change, but it's actually the responsibility of the subject to say that yes, indeed, I have changed the state. That's why subsequently you see a notify call called by the subject to say, yes, my state has actually changed. Now that notify call could go out to all the observers. That will go out to all the observers. So it's not like it's a one-time, one-one relationship. Here's what observer.h looks like. We have a virtual void here, so this is a pure virtual that is not going to be implemented. Well, it is going to be implemented, I should say, but it's not going to be instantiated. We have another virtual here for subject. The concrete subject actually does the set state, and then inside there we're going to do the notifications. Now the concrete observer has a list of subjects because observers can also have multiple subjects. So you can imagine that one observer could be registering itself against multiple subjects, all of which need to notify it of any particular changes. Here's our list of, in observer.cc, this is our list of, or in subject.cc, this part would be in subject.cc here. This is our list of observers that are attaching to ourself and then detaching. And then this is actually subject. This is a typo here. This should be subject.cc. So for all of the observers that exist, we do an update call on it. There's observer.cc. In observer, I'm sorry, this is concrete subject CC. Another typo here. In concrete subject CC, we've got a set state call, and it makes a notify, which is going to notify all the observers that that state has changed. Now, way down here in main, we have concrete subjects being created, and they're registering themselves against certain subjects. So O1 is attaching itself to subject 1. O2 is attaching itself to subject 1. Then we call set state on it, and we get behavior that looks like this. So we're in s1.state set state of 5. So observer 1 is querying subject S1 for a new state that's being set to 5. So consequences of this, the observer pattern lets you vary subjects and observers independently. You can reuse subjects without reusing observers. You can go vice versa. It basically, okay, so look, this is basically a way of saying we have one object that needs to know about an update on another object. So we're going to register ourselves on that object that is in control, basically, the subject, because the observer needs to know that any potential updates or anything happened on the subject, and so it has to register itself there. It has the effect of abstracting that coupling between these two things, because quite often in computer science that we're seeing that this pattern would happen over and over, where one object needed to know of updates or notifications or some other kind of information on a different object. So it abstracts that coupling, and we get to talk about that coupling more now. Also, it should be noted that observers don't have any knowledge of each other. So when they're binding, it could mean that an innocuous operation to the subject might actually have a whole bunch of updates to various observers, and those observers wouldn't know that those are happening. But, that's just something you plan for, and we do have a partial solution to that near the end of these slides here. So the simplest way for a subject to keep track of the observers would be to notify and store its references explicit to the subject. If we're observing more than one subject, then it might make sense in some situations to carry more than one subject, obviously. The question becomes who's going to trigger the update, and the code I'm going to show you does it in sort of the second fashion here. Either the subject can notify the update, the subject will call notify in that case, or the client would call the notify. The difference there is that, let's say we're in a subject and we're doing a set state. This is probably the preferred method. I'm going to actually show you the second method, which does a set state, which basically says that state is set to new state, but notify is never called. And in that case, we do an automatic call we do an explicit call to notify. Some people prefer that approach. That's why I'm going to show you that secondary approach there in code. So some things to note about the implementation of the observer. is that we can end up with dangling references to deleted subjects in this case, or maybe a subject was deleted from an object, but that subject was never taken care of. We also want to make sure that the subject is self-consistent before the notification occurs. In other words, that all the state changes have happened. There's no sort of errant temporary variables in there that are pointing to one state while meanwhile it's in a different state. So there's the push and pull model that gets after more information from the subject. The idea here would be that the pull model would basically say that the subject is going to only send minimal notification, and the observer would ask for more update information if it needed it. The push model would dictate that basically it sends all the update information it possibly can over the pipe. Now, this is one potential solution to the idea that, well, what if, that I posed before, what if an observer is only interested in certain aspects of the subject? In other words, what if, like, for example, we're going to have an example here shortly with a customer database where there's a welcome letter and there's an address, and so if the address is updated, we need to know for generation purposes of the welcome letter that the header of should change. So an address update might be one thing, but if we need to know something else, such as I don't know, the political affiliation of the customer change, or the credit rating of the customer change. Those might be aspects of the customer that we don't care about for the purpose of generating a welcome letter. We may only care about the address, so that's why this has an aspect associated with it. And so if that particular aspect has been updated, then the observer will get the update. If it hasn't been, it won't get the update. So here's an example of all of that running. So I'm going to run something called observer test, which basically goes into a welcome letter update and an address verification. Those are the two observers. So what's going on in this customer database is basically, let me show you in Sublime. There's a few files associated with this. Basically, the observer is just a very simple observer that doesn't really have much of anything. It's pure virtual. And the different types of observers are the address verification step here and the welcome letter, which can be generated. Those are observers into the customer. So the customer is just this database type object which has an attach and detach. So when it's attached, it attaches, like, for example, the address verification and the welcome letter. When it has to notify those things, it calls myobs update. And you'll see in customer test, notify is actually called outside. So this is the second method I had for doing this, where it's explicitly calling the notify. So we're attaching the welcome letter. We're attaching the address verification service. And then we're notifying that those attachments have occurred. Here's just the make file for this. You can see that we're doing observe test here. And so I put the code for this up on D2L, and what I'm asking you to do for the lab is pretty straightforward. Basically saying use that observer pattern from class, download the files, get them to work in either Visual Studio or GCC. I have it working here in GCC with a make file. You would just simply add an extra object file to be compiled here, like my component.o or whatever you want to call it. And then to prove that it's working, so to make sure that when you call it, it gets into those routines. So here we're in an update of address verification. You're going to make your own update to do stuff, and then you're going to attach it. So it's pretty simple actually. Then you're going to attach it here. And then since you've attached it, notify should get called. And that's sort of the magic of the pattern, is that notify should then automatically get called as long as it's attached. Then you've understood the assignment essentially. As long as it's attached, then it should get its notification step, and you should see that output. All right. Well, I will be uploading this video shortly here, and your lab is due on Friday. We will see you again on GoToMeeting on next on Wednesday morning for this class at 8:45. I've got a couple other classes that run tomorrow morning, and then I've got data structures that runs Wednesday morning right before this class. All right. Thanks.